Hello students, today we're going to cover section 6.1, polygon angle sum theorems. Our learning goal for today is to find the sum of the measures of the interior angles of a polygon, to find the measure of a single interior angle of a regular polygon, and to find the measure of an exterior angle of a polygon. One of the primary theorems that we're going to use today is polygon angle sum theorem. And it states that the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. There's a very specific reason for this. One of the things that we've known for some time now is that the sum of the angles of a triangle is 180. So in this case we have a regular triangle or an equilateral triangle, meaning all the sides are the same. And because of that we know that each of the three angles is 60 degrees. Now we know from triangle angle sum theorem that the three angles of a triangle always have a sum of 180. That's nothing new. This new theorem allows us to extend that just slightly. And the reason for that is because if we start dealing with polygons other than triangles, we can see that if we take any singular vertex and connect it to the other vertices, so we connect this to this vertice, and we connect this one over here to this vertex, you'll see that we now have 1, 2, 3 triangles. So the pentagon started with 5 sides, but we end up with 1, 2, 3 triangles, or 5 minus 2. Since each one of these triangles has a sum of the interior angles of 180, that's where the multiplication by 180 comes from. So here you can see we take 5 minus 2, or the 3 triangles, and multiply that by the 180 degrees that appear in each triangle, and the formula holds true. We have number of sides 5 minus 2, which gives us the 3 triangles, times 180 degrees because there's 180 degrees in each triangle. And in this case we can see that the sum of the interior angles of a pentagon is 540. So when we want to find a polygon angle sum, the question might look something like this. What is the sum of the interior angles of a 17-gon? Now remember, a 17-gon is just a polygon that has 17 sides. So it's important that we remember the formula from the previous slide. That's n minus 2 times 180. And in this case we know that n is 17, so we're going to go ahead and plug in 17. So this is going to equal 17 minus 2 times 180. 17 minus 2 is 15, so we have 15 times 180. And 15 times 180 is 2,700. So the sum of the interior angles of a 17-gon is 2,700 degrees. So a second question might say something like, the sum of the interior angles of a polygon is 1,980. And they might ask us to find the number of sides that that polygon has. The formula in this case is exactly the same. We have n minus 2 times 180. The only thing is now we know the end result. We know that this equals 1,980. And now we want to find the number of sides, or we want to solve for n. So our first step in this case is going to be to divide both sides of this by 180. So we divide over here by 180 and divide over here by 180. And when we do that, we find that n minus 2, the remainder after we cancel here, equals 1,980 divided by 180, which is 11. And in order to remove the minus 2 from both sides, we can add 2 to both sides of this equation. So add 2 over here and over here. These are going to cancel, and we find that this is a polygon that has 13 sides. So how can you find the number of sides of the polygon? We just reverse the formula. Okay, so some new vocabulary here. We already know what an equilateral triangle is. We know that that's a triangle that has 3 congruent sides. So an equilateral polygon is just a polygon whose sides are all congruent. We've talked about equiangular triangles before. So the definition for an equiangular polygon should not seem unfamiliar. An equiangular polygon is a polygon that has all of its angles congruent. And finally, our new vocabulary word, a regular polygon. A regular polygon is a polygon that is both equilateral and equiangular. So then we have a corollary to the polygon angle sum theorem. And it states that the measure of each interior angle of a regular n-gon is n minus 2 times 180 divided by n. So if we think about what's going on here, we're finding the sum of the interior angles of a regular polygon, and that's given by this top part of the formula. So this is the sum. And then by dividing it by the number of sides, we split that into each of the angles. So in this case, this is a regular hexagon. So we find the sum of the measures by doing n minus 2 times 180. And then to find each angle, we divide by the number of angles. So the second type of question we'll see, it'll ask, what's the measure of each interior angle of a regular nonagon? So first things first, it's important to know the titles of all of these different polygons. So this is a nonagon, and a nonagon has 9 sides. So that's one of the most important things for this question. So we need a 9-sided figure. So here we have a nonagon. This is a regular nonagon. Remember that being regular means that all of its sides are the same. So the first thing we want to do here is find the sum. And in order to do that, we're going to use the formula from one of the previous slides, n minus 2 times 180. And that'll give us the sum of the interior angles of this nonagon. So we're going to take 9 minus 2, so we have 9 subtract 2, which is 7. We're going to multiply that by 180. So we have 7 times 180. And this is going to give us 1,260. The second thing that we want to do is to divide the sum by the number of angles. So we have the sum from the previous portion. We have 1,260. And we want to divide that by 9. And that's going to give us the result of 140 degrees. So each one of these angles inside this regular nonagon is 140 degrees. So they're all 140. So another type of question we might see is the find the missing angle measure type question. So here we have a quadrilateral EFGH, and three of the angle measures have been given to us. F is 120 degrees, E is 85 degrees, and H is 53 degrees. And we want to find the measure of G. So thankfully, again, because of polygon angle sum theorem, we know that we can use the formula n minus 2 times 180 in order to find the sum of the interior angles of this quadrilateral. So this is a four-sided figure, so we're going to plug 4 in for n. So we have 4 minus 2 times 180. And 4 minus 2 is 2, so we have 2 times 180. And 2 times 180 is 360. So we know the sum is 360. Now we have 3 of the 4 angles. So we know that what we have already is 120 plus 85 plus 53. So we know that the sum is 360, but we already have $258. So if we take what we already have, the 258 degrees that we were given, and take that away from the sum, which is 360, we can see that the remainder is 102. And that tells us what the measure of G is. Now remember, we've talked about exterior angles before, specifically when dealing with triangles. We can find the sum of the measures of the exterior angles. So remember, if this angle is 100, this exterior angle, because of the linear pair postulate, is going to have to be 80 degrees. 180 minus 50 is going to tell us that this one is 130 degrees. And finally, 30 is going to have to give us an exterior angle of 150. So if we take what we know, we have the 80 plus the 150 plus 130, we'll see that that's 360 degrees. So the exterior angles of a triangle add up to 360. Let's try it with a quadrilateral. Okay, we find a 115 degree exterior angle here. Here we have an exterior angle of 75. Here we have an exterior angle of 99. And finally, the 109 degree angle has an exterior angle of 71. So we take the 115, the 75, the 99, and the 71 and add them together. It comes out to 360. So it doesn't seem to matter how many sides the figure has. 3 sides, 360 sum. 4 sides, 360 sum. So no matter how many sides the figure has, if you take one exterior angle at each vertex, they are always going to have a sum of 360 degrees. So the polygon exterior angle sum theorem says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360. In this case, this pentagon has one exterior angle at each vertex, so the sum of the angles is 360 degrees. So if we want to find the measure of an exterior angle, and here we're trying to find the measure of angle 1, we're trying to find the measure of this angle right here. One of the first things that we need to do is find the measure of the interior angle. So in this case, we start by finding the sum. We have our formula, n minus 2 times 180. And in this case, because this is an octagon, we're going to plug in n equals 8. So we have 8 minus 2 times 180. 8 minus 2 is 6, so we have 6 times 180. And that's going to give us a sum of 1080. Now, if we take the 1080 and divide it by 8, we can find the measure of each interior angle. And that's going to give us a total of 135. 1080 divided by 8 is 135. So each of these interior angles is 135. Now, by the linear pair postulate, if an interior angle is 135, each of its exterior angles are going to be supplementary, so they're going to be 45 degrees. Now, this is actually the long way to do this problem. The previous slide, we found that as long as we take only one exterior angle at each vertex, we know the sum is 360. So if we have 360 degrees and we divide by how many exterior angles there are, as long as there's only one at each vertex, 360 divided by 8, we'll find that 360 divided by 8 is in fact 45. So the results are the same. The main key here is having only one exterior angle at each vertex. Hopefully you enjoyed today's presentation on section 6.1, Polygon Angle Sum Theorems. Don't forget to take the quiz, and I will see you guys tomorrow.